to introduce his piece Icarus at the Edge of Time. You know, I encountered the original myth of Icarus when I was quite young. Actually, keep the lights up. It's Sunday afternoon, after all. Keep the lights up a little bit in the audience. You know, I encountered it when I was quite young, and I think many kids have. I mean, of the kids who are here, how many know about the original myth of Icarus? Yeah, quite a few. So, you know, it's a story about a boy, you know, he has wax wings, his father constructed them, and father tells him not to fly too close to the sun, and he does fly too close to the sun, and, you know, what happens next? Let me tell on someone completely at random. That young man, right over there, what happens when Icarus flies too close to the sun? He dies, that's right. And for the young man.
He dies.
Tells me completely at random. It happens to be my son, 5 years old. So he dies, and that struck me as odd because, I mean, you know, just to review, class, a young boy defies his father and he dies. That just struck me somehow as wrong. And as I got older, and as I became ever more interested in science and became a practicing scientist, the myth became even stranger to me because I learned, as we all know, that to have a great breakthrough in science, or really in any field, but science in particular, you have to go against your fathers, what happened before. I mean, think of the great scientists throughout the ages. Galileo, Newton, Maxwell, Schrödinger, Bohr, Heisenberg, Einstein, all of them went against what happened before. They had to, if they were going to push the envelope of understanding. That's what it means to have a breakthrough. And you don't die, but you do cause something else to happen. Great breakthroughs can force us to acclimate to a new way of thinking, a new way of seeing the reality around us, and that can be a painful transition. And that idea is really what inspired this reimagining of the myth of Icarus that we're going to see played out here this afternoon. A boy doesn't die. Something else happens along the lines of what I just mentioned. In many ways, it's quite a painful journey for this boy, but as we'll see, it differs substantially from the ending of the original myth. Now, this version also differs from the original in another way. The story is definitely fictional. There are technological elements in the story which today are fictional. Who knows, maybe in the future they won't be. But I want to stress one key thing. The science underlying what you'll see happening in this story, the fundamental science, is fact. Non-controversial fact. It's science that comes from Einstein's general theory of relativity. And, well, we all live busy lives, I know that. And sometimes because of that, we let our knowledge of general relativity get a little bit rusty. It's nothing to be ashamed of. We're all friends here. And that's where I come into the discussion here, because I'd like to now give you a 7-minute primer on the general theory of relativity to get your mind geared up for the little story that we're about to see. So general relativity, it is a theory of gravity, gravitational force. And the story of gravity actually predates Einstein substantially. It was Isaac Newton in the late 1600s who wrote down the first quantitative understanding of the gravitational force. A little mathematical equation. I suspect many of you know it quite well. F equals G M1 M2 over R squared. Thank you very much. So that little equation is what Newton wrote down, and it allowed him to make predictions about how things would move. So just to get us all on the same page, this is the usual context in which we think about gravity doing its thing. We have the sun, the earth in orbit. We look at the other planets as well. And that little mathematical equation lets you predict where the Earth and the other planets should be at any given moment. And the wonderful thing is, you look up into the sky, and the planets are just where the math says that they should be, which is a very convincing demonstration that Newton had taken a substantial step toward truth. Thing is, early part of the 20th century, when Einstein came along, Einstein was this maverick thinker who would really look deeply into everything, even ideas that everyone around him thought had been settled centuries before, among them gravity. And he began to think about gravity, and he asked a very simple question. A question that you may have heard from your kids when they're 3, 4, 5. The question he asked is, how does gravity actually work? You know, you see the sun, the earth, there's nothing connecting them, but somehow the sun affects the motion of the earth. There's no rope between them, no big arm that's sort of reaching out from the sun and clutching hold of the earth. And, you know, even closer to home, you know, if I take any object, I let go of it, you know what will happen. But how did that happen? What's pulling it down? Of course it's gravity, you say, but what is gravity? How does gravity affect things? How does it get the job done? So Einstein did the natural thing. He went to a famous book of Newton's, the Principia, to try to think about what Newton had in mind when he was discussing and investigating gravity. And Einstein goes over to the big book and goes to letter G for gravity and finds that little formula that you guys reminded us of just a moment ago. And then he goes a little further for the subheading M, the mechanism by which gravity operates, and he comes upon a very surprising statement. I'm sorry, I think I just spit on you. A very surprising statement. I'll try to step a little further back. Very surprising statement, because Newton says, I don't know how gravity works. I have this equation, it seems to make accurate predictions, but how gravity gets the job done, I've not been able to figure out. In fact, in his own words, he said, to that important question, the mechanism by which gravity operates, he said, I leave it to the consideration of the reader. Now, most readers, they read that and they read on. Einstein was different. He saw this as the great challenge, and he spent 10 grueling years trying to figure out how gravity actually works, and finally, he sorted it out. And the answer he came to, again, I think really crystallizes the amazing intellect that Einstein was, because if here's the sun and here's the earth, everybody was stymied by the fact that there's nothing in between them, effectively empty space. Einstein said, well, it must therefore be empty space. That is the medium for transmitting gravity. Now, how do you take that strange idea and make sense of it? Well, Einstein said maybe space is kind of like a trampoline that can bend and warp. And by virtue of those bends and warps, it can push objects around and make them move in a manner that we usually associate with the force of gravity. So let me just show you what that would look like. So this image here, that's space. That's 3D space, the stuff that's all around us. A little hard to get your mind around 3D space. So if you go to the two-dimensional version, it has all the essential ideas. You see it's nice and flat like a trampoline when nothing is there, but if you put the sun in it, the trampoline of space warps. Similarly, the Earth warps space around it, and focus your attention on the moon, because this is the point. The moon is kept in orbit because it's rolling along this valley in the curved environment that the Earth creates. That pushing of space on the moon is what is the force of gravity. Similarly, the Earth, too, is kept in orbit because it is rolling along this curved environment that the sun creates. That's the basic idea of how gravity works according to general relativity. Now, this idea came to Einstein between 1907 and 1915. He publishes this result late in the fall of 1915. He sends it off to the journal. It's published in early 1916. And just a few months later, a German astronomer, mathematician, meteorologist named Karl Schwarzschild, who was on the Russian front in World War I, gets a hold of this paper, and somehow in the drama and the danger and the chaos of war, Schwarzschild sits down and starts to do... I'm sorry, I spit on you again. I'm really going to...